Right, guys, might as well make a start. So, just want to say, first of all, Happy New Year to everyone. Not sure if it's too late to say it, but never mind, it's still January, counts in my world. Just want to say this is our first event of 2018 in the IC, and before we start, we've got no fire drills planned tonight, but the emergency exit is just over there to my left or your right, so hopefully we won't have any issues tonight. So, we've kindly have gotten Neill Pawsey from Costain tonight to talk us through Building Information Modelling, or BIM. And just as a matter of interest, how many here were here for the industry talk back in November? So, okay. Well, we got lots of new people who are going to be have a great introduction to Neill, in that he's a very good speaker, certainly helps to break down BIM and other complex issues into small parts and possibly put them back together again. We'll see. So if you all wanted to give a round of applause to Neill, and Neill, do you want to come up and join us?
Thanks, Hugh. It's good actually that you're a fresh audience, because I might run the risk of repeating myself a little bit. So yes, my name's Neill Pawsey. I'm the grand title of Head of BIM for Transport Sector Advisory, whatever that means. So I'd like to do today, I suppose the challenge that Hugh set me is to demystify what BIM is, and secondly try to set out BIM as an opportunity, or digital as you'll hear me calling it, as an opportunity for the future in terms of skills that are needed, certainly in this country and probably arguably globally. One of my jobs is to provide digital advisory services to a number of big clients in the UK. We're currently doing quite a lot of work with Highways England, but we're also engaged with Network Rail and also with other public sector departments and directorates who are being driven currently by the UK government's BIM imperative, you can call that. And we just can't, a bit like the engineering situation in this country, we can't find the right people with the right skills to drive this forward. So I'll touch on that a little bit. So by way of introduction, I've been extremely lucky in my career. Apart from 3 years in the British Army, I spent my entire life in civil engineering and construction, and I've enjoyed every minute of it. And I will tell anybody who comes to me, young or old, what a great industry it is and what great rewards are to be had, and I hope you agree with me about that. I've been lucky. I've picked 4 projects here, and I'm going to ask you to identify them, so think about it for a moment. I've been lucky to have worked on all of them, and there's something that sets each of them apart. So let's just run through each. Probably the hardest one is top right. Does anybody want to hazard a guess as to what that project is? Shaking heads, bemused expressions. Jeff, you're not allowed to answer because I said it before on my previous talk. No, it's not in the UK. That is actually Samsung's shipyard in South Korea. And the structure that you see there is, and I'm not allowed apparently to call it a ship, it's called Prelude. It's a floating liquefied natural gas processing plant. Why is it important? Well, it's 500 meters long for a start, so it's one of the largest floating structures ever constructed. It's the biggest thing that Samsung had ever created in their yard, but also the most complex. So the complexity of being able to build it essentially in modules and put it together in the right way so that each module interfaces in the right way had to be done in a slightly different way. So digital techniques, I'll explain a little bit more about that, were at the forefront of that project in optimizing the way that floating platform was put together. Who knows what this is? Next one, top right. I said top left before, didn't I? Say top right. Hazard a guess at what that one is? It's been in the news a lot, particularly last year. It's Hinkley Point C out on the Somerset coast, so new nuclear power plant. I worked there for 2 years, client side, as the head of information management for EDF. First time a nuclear plant's been built in the UK for, wow, 40 years possibly, which was Sizewell C. So a lot of expertise has disappeared out the door, being built by the French and to a certain extent by the Chinese. So most power plants of that type around the world, in China, in Finland, in France, all over budget, all running over time, realised that it has to be done on time. They can't afford to be billions of euros over budget for that particular project. So using digital techniques, a concept called the virtual power plant. I'll talk a little bit more about what we call a digital twin later in my talk. So bottom left, get my left and rights right this time. So that doesn't really give much away. That's Masdar City in Dubai, in Abu Dhabi. Sorry, not Dubai. Anybody heard of that? So an older project, but a city in the desert, built to very, very high environmental and sustainability targets. Has no cars in it. Has a rapid transit system in it. All the power for that city is generated by solar power. All the water is desalinated from the sea. It's a concept city, really. Again, a high level of digital engineering, digital construction, digital operation techniques used in that project. And then this one, bottom right, should be a little bit easier to identify because it's not very far from where we are now. Anybody want to hazard a guess what that is? None of you have spoken up yet. Yes, it's Crossrail. So I spent 4 years on the Crossrail project, again, client side, as a senior project information manager. And you know, Crossrail is very prominent in the news. You may well, I don't know if you've had talks from Crossrail folk. Some of you in this room may even be involved in that project, but by any definition, it is a world-leading project in the way that it is driving construction and engineering techniques from a digital perspective. Arguably, because, and you may be somewhat cynical about this, it's within its funding envelope and largely on time. So for something in this country to be delivered like that, of that size and complexity, is really unique and sort of built on a lot of the lessons that were learned from London Olympics. It actually goes all the way back to Heathrow Terminal 5, because up to that point we didn't have a particularly good reputation in the UK for delivering complex infrastructure. So 4 projects, all using digital technologies, arguably BIM. I use the word digital and BIM very closely together because I actually have a problem with the acronym. So let's get straight to it. So how many of you in this room have heard of the word BIM before, by a show of hands? Good. How many, by a show of hands, actually know what it means? Less. Well, actually only 2 hands. That's appalling. That's probably a line. Anybody want to hazard a guess of what they think BIM is? Anybody going to be brave enough to volunteer it? Didn't think so. Okay, so BIM is a much maligned acronym. I'm increasingly falling out of love with it. It's a lot of hype around it. Lots of people will tell you different things. I think I remember a number of years ago we put something out on LinkedIn that said, give us a definition of BIM. I think we got 80 different interpretations of what it was. There's also lots of other acronyms that are associated with BIM, and some of them are up there in that sort of wordle that you can see in the centre of the slide. But really the word at the bottom is probably paramount. It's a lot of people are very confused about what it is. It's actually not as hard as you think. It's a very simple concept. The idea of managing information, and that's the I in BIM because it stands for Building Information Modelling, is the most important thing. Information management is not a new thing. We've always needed information to design, construct and operate our facilities or whatever asset it is that we are constructing. The pyramids were built thousands and thousands of years ago, and the information needed to build them was described on what? I'm going to get interactive with you lot if it kills me. Papyrus. Who said papyrus? Jeff said papyrus because he probably heard me say it before. But he's right. He's absolutely right. So the information that was carried to the guys in the field and the engineers and the architect was written down, information on bits of paper. What has changed in those 4,000 years? What's that, Hugh? Yeah, that's kind of it. It's the technology. Yeah, the way that we can capture that information and make it available is manifestly different. And those of you that have been in the industry as long as I have, and I can see some in this room have, will realise or have experienced the advent of things like CAD, so moving away from drawing boards to electronic 2D design, email, which created as much confusion and also I think it didn't really improve the quality of information or how it was flowed, let's put it that way. To certainly improve the speed, let's put it that way. You'd have seen things like PDFs suddenly appear, you know, standardization of file formats and things like that. We've been through a huge change in the last few years, but the need to manage information has not changed. So, you know, what exactly is BIM? It's difficult to find a consensus. Here's a description from Crossrail, okay? One of many that you can find. So I'm not sure if that enlightens you at all, but what I would say, this is my own interpretation, put more simply, if you, whoever you are, during whatever phase of a project, can get the right information that you need, not too much, not too little, Goldilocks Principle, and you have it made available to you in the right place, in the right format, at the right time, and you trust it, the argument goes, you are likely to do your job better, or put more simply, you are likely to make better decisions. It is as simple as that. So if you harness new technology and understand that information flows through the life cycle of the project and how it does so, then you're beginning to get the gist of what BIM is, okay? It's not 3D modeling, it's not nice geospatial maps, although that's part of it, that's a way of managing information. Many software vendors would have you believe that you can buy BIM out of a box. I'm not going to mention any vendors in particular, but you'll probably know the likely contenders within our industry. And I'm not ascribing blame to each, it's just that, you know, if I was a software manufacturer, I think I might exploit that opportunity as well. So they've been part of the problem in confusing what actually BIM is, and I think I'm arguing that it's actually something a lot simpler. Get the information, make it right first time, better decision making leads to better efficiency. Is everybody clear on that? Did that make sense? So just following that theme, so again, you know, the old world and the new. So in the old world, information was kept by many parties. So if you were an architect, you would deal with the information pertaining to you. You were trusted with it, and then you would pass it to somebody else, who would pass it to somebody else. And during those exchanges of information, I'll come back to that in a minute, there's a exchange of information between different parties and people, but there's an exchange of information the life cycle of a project, which I'll talk about in a minute. So every time that information is exchanged, traditionally it will be done in different formats, and basically information gets lost and you get waste, and we don't want waste. So it was quite an inefficient way of working. Perhaps we didn't realise how inefficient it was until now we know we could probably do things better. So BIM is basically saying if everybody uses the same source of information, the same central hub, in the same format, okay, so that it's interoperable, it's exchangeable, it's much easier, much more trustworthy, much more easy to manage, much more visibility and transparency about what that information is. Again, that's another principle of BIM. It's not only to make that, as part of making information trustworthy in one place, you need a system to house it in. And again, I'll come to that. So the other point I made was about the whole life cycle of information. So our industry is notoriously siloed by discipline. And actually interesting, sitting here in the Institute of Civil Engineers, you could argue that some of the professional institutions are responsible for creating some of that siloing. We all have jokes, don't we, if we're an engineer, about an architect or a designer, somebody out on site, you know, we make jokes about it. But those professional barriers actually matter when it comes to managing information. And so does it in the information cycle of, so I picked something here, this is actually from oil and gas, okay, so hopefully this is easy enough to follow. So you've got some very basic phases in the life cycle of a project, from conceptual design through design engineering through production to as-built to handover. I picked a pump or a valve, for example. So what you know about that asset very early on in conceptual design is probably, you know, some certain basic things that it needs to do, and that's information, and it's associated with that asset. And as it goes through its life cycle, and that's in the boxes down the bottom, we know more about it. In fact, when we start detailed design, we know more about it. When we fabricate it, when we install it, we know more about it. And actually during construction it's quite important because things tend to change quite a lot. We may change the design, and we need to record all that information because it's really important. Who for? It's really important for the person at the end who's handed over to, who has to operate it. So that information has value. What's actually happened, and you've got a little red dotted line there, is that in I say current practice, it's getting better, but this slide is a bit old. At each point, each boundary layer between that life cycle, information gets lost. Picture it another way. It's a bit like guys and girls sitting behind walls, working away in their own way. They do what they need to do, and then they throw it over the wall to somebody else. They don't really care, or haven't traditionally cared about the next phase of the life cycle, just care about what they're doing. And in throwing that information over, some of it gets lost. Some of it is waste because it's information that the person receiving it doesn't really need. So you see this kind of sawtooth growth of information. And on the left, I've described it as data, knowledge, and information. And that's a very simple premise in information management. If you have good data, that leads to good information. So information is data that's useful. Knowledge is derived from good information, and then that always the way it goes up to what they call wisdom, really, which is probably a decision making. Okay, so that's sort of the value of the information on the left. There's another way of looking at it, rather than the sawtooth, is that you could say, well, you just capture as much information as you can just to be safe. Well, that's equally inefficient, because you end up with too much information. Some of it is wasteful. So what you actually need is this nice, smooth, yellow line, this optimal transfer of information. And if I was to plot at any point, to my point earlier, that if I was to interrogate that information at any time, depending on who I am, I just need to know just enough information that's going to help me do my job. Okay, so that yellow line just means optimal growth of information. Okay, so you're following me so far? Haven't lost anybody yet? Good. So a lot of people will go on, particularly the software providers, about systems that manage information. And I think one of the things we often get wrong these days is that we allow systems and technology to dominate, when actually what we need to be thinking about is the information itself, agnostic of and separate from any system. Nevertheless, if you remember my old diagram about 2 slides back, the old and the new and the central hub of information, well, that is referred to in system sense as a common data environment. Okay, you often hear that word bandied about. So a common data environment doesn't actually have to be one system. Why is that? Because the types of information that we often need in design, in construction, and into operations will vary in type. We may have 2-dimensional drawings, we may have 3D models, we may have asset information, tables of information, we may have documents. In fact, on most projects we have more documents than anything else. And you can have different systems that manage all those different types of data, because lots of software providers will do systems that are good at doing certain things. So CAD software, good at doing CAD. 3D modeling software, good at doing that. You won't find the sort of Lord of the Rings principle. You won't find one ring to rule them all. It just doesn't work that way. And in fact, many software providers who have tried to provide those kind of things often fail. So the notion of a common data environment is not one system. It could be many systems, and they call that federated. So they link together. And that's a really interesting part, is that how do you get systems to talk to each other? So the first thing you need to do is describe in data terms how data fits together. And often you do that very simply by ascribing them a very unique identification. And I'm sort of grossly oversimplifying things here, but that's the way that you could describe in a data map how things fit together. And then that becomes a very useful requirement that you can send to a software provider and say, actually, I want a system or a group of systems, or I want your system, Mr. Software Provider A, to talk to that software provider's system as well. Most software providers at the moment won't do that. They'll quite happily sell you their own systems and make them talk to each other. And what we're trying to do in our industry is drive those software providers to be more open in the way they exchange information. So we're almost saying to a software provider, you know, I'm going to buy your software not because it's good, but because it actually talks to your competitors' software. And that's quite a unique change in our industry, but it's starting to happen, and you see things like neutral data standards being prescribed. The PDF example I gave you before is a really good example of that. The PDF, arguably, is a neutral standard. Lots and lots of different software know what a PDF is, can store it, can view it, and make it available. It's not proprietary to any one software provider. It may have started that way, but now it's not. So a common data environment, as I've described here, is that central repository. It's that thing that you're going to use, be it on a mobile device or on your desk, that gets you the information that you need. It's the system that provides it. And it may interact with many other systems as well. So a common data environment may not just be asset information, it may not just be models and documents, it may also be financial information. At Crossrail, certainly the common data environment where I worked encompassed many, many systems working together to give you that access to the information. It didn't actually matter for the everyday person who was using it what that looked like or how it was wired together. What they more cared about is what it actually looked to them when they logged into their machine in the morning and just got to see what they needed. So you don't really need to understand what they call the system architecture underneath it. You just need to understand that it is a one-stop shop for you to get to the information you need. And then when you've got all this data in one place, you can go what they call mine it. You've got all these wonderful new jobs coming out now of people called data analysts. And I have a few in my team. I don't really understand what they do, but they can actually do some really, really fantastic things with data and turn that into really informative bits of information that will help people do their job better. Display it in ways that people want to see it, and they're very good at manipulating that. But you need a system to do it. And the little boxes around the outside really give you just some examples of how people might want to see their information. If they're I don't know, if you're a client, you might have your delivery partners, you'll have your project teams, you'll have your engineering teams, operations, and other people will all want to see their information in different ways. And the power of these systems is that it can display, slice and dice this information in any way so people can see it. So what's the benefits of working this way? So if you know more about something, then you don't have to apply so much contingency and risk to it, because you're dealing with more information. That should be logical. If you have a single source of truth, and you can notice this is all about good decision making, you're going to reduce the errors that are made. And the really great thing about errors in the digital environment is that if you use that data to model construction, for example, it's much less expensive to put it right in the digital world than it is to correct the defects in the physical world. And those of you that have been in the industry know just how problematic that is. And also, if you do it right, you can foresee those things in advance. You can actually model your construction sequence in advance and do it safely, so you're not putting anybody in danger, and also cheaply. Okay, so if you've got all that data up front, all that power right up the front of the project, you can start to simulate the way you're actually going to build something, and you can actually start to simulate how you're going to operate something. And it's a lot cheaper and it's a lot safer to do it that way. The information loss that we had in the phases that I showed you before, and the information loss that you have between professionals, will be reduced if you're all using the same system and you're all working in the same way. Talked about safety. So the example I kind of gave there is what they call 4D. I'll talk about that in a minute. Is that adding time to 3D models, playing that through time, and seeing how that affects the safety of the people around. The most obvious example I had was in the nuclear industry, where they took a principle called ALARA, or ALARP, which is radiation exposure. It's an algorithm. What they were able to do with the 3D models, this is even before the plant was built, is simulate the actual built structure with avatars of people moving around the building, and they could simulate their radiation exposure for normal, routine operation and maintenance activities before the thing is built. So they know where the safe places in the plant is. They know how their operators are or are not going to be put into danger with radiation exposure, and that's all done before it even happens, and it's all done without actually putting people in harm's way. And that principle can be applied in many, many aspects of construction and operations. Example we had in Crossrail was signalling. So I think on the overground section going out of Reading, they had a train, they put a laser scanner on it, and they scanned the entire rail route, and then they took the designed model, and then they stuck drivers in a room, and they played them this video with the existing track and the new infrastructure and the new signals, and then they tested whether they could see the signals at operating speeds. And if the drivers couldn't see those signals, it led to a design change. So it's much better that it was discovered then than when the thing was actually built. You'll hear the word collaboration used a lot in BIM. Well, what does that mean? It's not a word used actually used in Europe quite a lot, because it has connotations with the war. The French seem to think it's sort of conspiring with your enemy. But it's about working better together and working smarter together. Yeah, we had big problems with the word collaboration in EDF Energy. That just had to be solved in a slightly different way. So it's collaboration between people, between teams, working smarter together. That implies trusting each other, exposing information to people that traditionally you wouldn't have done before, but also getting your systems to work and collaborate together. So I touched on the idea of having these neutral data standards so that systems can actually talk together. So if you leverage all those things that I've talked about, then you're arguably going to get more effective project delivery. Now, I've touched on one or two things in there which sort of lead to the idea of change, and I'll come back to that in a minute because that's a big challenge. It's also a big opportunity around BIM because it's actually getting us to work in a way we're unfamiliar with. So one of the things I discovered at Crossrail was that was quite a significant challenge, getting people to understand that sharing information, working in different ways, challenged the way they were working already. And human beings are irrational, fundamentally. And one of the reasons why I have very little hair now is because I have underestimated that challenge throughout my career. I am an engineer. I deal in predictability. So when I have designed things, when I've worked on sites, I want absolute precision. I want to know exactly what's going to happen. Human beings are not like that. You may well come away from this lecture, despite the fact I may well have done a good job in explaining to you, and you may also think I'm balmy. You may not agree with me. You may have your own irrational perspective on what I'm saying. That's your right as a human being, and that's what we deal with. So BIM and digital is a manifest revolution in this industry about the way we do things. And one of the reasons why it has gained little traction over the years is because people have underestimated that it's about change. Now, one of the things that Crossrail really did well, I think, and I think these were lessons learned from the Olympics and Terminal 5, is to buy people into an ethos, that you're part of something big, you're part of changing something, and introducing new and novel concepts into that dialogue. Now, one of them, and you may hear it if you're involved in rail, is something called the digital railway. So at Crossrail, we were encouraged to think very much about the importance of data and the importance of digital in the same way that we think of it as being physical things. So we were told we were building two railways, the physical one and the digital one. And we were building them at the same time, and they were equally important. That was to try and get people to understand the importance of both. And that's a journey, really. At the beginning of when they were trying to do it, we knew that wasn't equitable. That wasn't an equitable dialogue, but towards the end, we were getting there. The analogy I would give you is health and safety. So I started out in this industry 30 odd years ago. I was out on site. I remember carrying bags of cement up a wooden ladder that wasn't secured. And then I turned around to my site superintendent at the time and said, you know what, I think this is quite dangerous. What do you think he might have said to me 30 years ago? Go and find a job somewhere else. But yet 30 years later, I turn on my site at Liverpool Street Station, Crossrail, and maybe I hadn't had a lot of sleep that night, and I walk up to the construction superintendent, who I know very well, who challenges me as to whether I am fit to be on that site, just because I look a bit peaky. Okay, so there was this philosophy of courageous intervention on site. Didn't matter who you were, didn't matter the seniority of who you were. If you're not safe, you're not allowed on that site. I never would have believed it 30 years ago that that would have happened. So health and safety, and all of you who work on site know it's endemic. It's ingrained into us now. If I walked on to Paddington site at Crossrail and I pulled my mobile phone out on the site, I guarantee within about a minute, less than a minute, someone would challenge me and tell me to put my phone away. Never would have happened 30 years ago. Why am I banging on about that? It's that same level of change of attitude that's got to happen with digital as it has happened with health and safety. So there's a challenge in that because it's taken a long time, but it gives me optimism that we can change. Just to finish off on this slide, and maybe I'm over-egging it a little bit, at EDF Energy, when we were building Hinkley Point, we were trying to get people to understand the value of data as a commodity. So out of the X billion pounds it's going to cost to build that facility, I challenged them to try and understand how much of that money was buying data. I'm not going to be specific because I can't be, but it's a significant amount of money. So if you're spending money on steel, if you're spending money on concrete and the machine that's going to generate power, as well as the people and the buildings and everything else that you need, you value those things. So you should value data as well. If you don't, then it's just waste. So you're actually throwing money away. So there's a cultural journey that people have to go on in this world, which will change thinking, and that's a significant challenge. So the next few slides are really a bit of a reflection for me on some of these challenges and some of the projects that have tried to address them. I've mentioned Crossrail, so I picked on High Speed 2 here actually. So if anybody goes on the High Speed 2 website, you will see that it has digital and BIM written all over it. They have a vision. You know, BIM is a change program, and if clients and if companies don't recognize that, they will fail. And to have a good change program, you need a vision. You need to know why you're doing it. And you need the leaders at the top of your organization to believe it and talk it. And that needs to be articulated into some words, like engine for growth, 21st century transport backbone. And then you need to sort of describe what actually good looks like. You know, if we go on this journey, what's going to end up happening? Well, we're going to build something to modern engineering standards and we're going to use the latest technologies. What does that mean? So BIM will form the information backbone of the High Speed 2 network through the life cycle of the project, eventually becoming the asset information model that everybody will use to maintain it. You may disagree with those words, but you've got an organisation and a project there that's aspiring to do something big. And you'll want to be part of that, and you'll hear all your leaders saying it, and that happened at Crossrail with Andrew Wolstenholme. And eventually that percolates down and you feel on a journey together. BIM's only part of the journey. You know, just because you believe in digital is not going to make you succeed. So you've got to have an overall vision for what you're actually building, and how BIM and how digital plays its part in that needs to be articulated. And without banging on about it, you need your senior project sponsors, your senior people to be selling the vision and acting as they say they're going to do. And again, you can see the analogies with safety. You want to see your senior managers out on site doing the things that they're telling their people out on site to do. The whole notion of BIM and information has to start somewhere, and I always believe that you start with the end in mind. Okay, so the government has produced lots and lots of documents. There are some standards. They're called the BS or PAS 1192 series. There are 5 current parts. There's plans to be 7. Basically, the early stages talk about how BIM, how digital can be mandated through the various phases of the life cycle, from design through engineering, through construction, through to operations. The latter part of the standards, like 5, are dealing with things like security. I might come back to that later. But it all starts with information requirements. It all starts with the owner of that asset. What do they want that asset to look like? How do they maintain it? If it's a nuclear power station, we've got pumps in there. So somebody's going to have to maintain those pumps. They're going to have to change belts on motors, and they're going to need to know how often that motor is going to fail. They're going to need to know the different parts that they need. So it starts with some fairly simple questions with the facilities owners about how they're going to operate the thing. That then translates down. So if you think of that question about how often do I need to change the belt, there is data, there is information that will answer those questions. And for each of those decision points, that will start to describe the type of information that you're going to need. So it starts with something called organisational information requirements. That's what's up there. It's the top level. And then you've got something called employers' information requirements. So once you know the information you want to tell the people who are building and engineering your facility to capture that information on your behalf. And you're going to need to put something into your contract that says not only are you going to build me something, but as you're building it, you're going to start providing me, the client, with that information. So something called an EIR is becoming common in contractual engagement now. So at procurement, you'll get an EIR. The EIR will tell you not only what information is needed, it will tell you when they need it, it will tell you what format it's needed. And then as a contractor, you will then be asked to submit something called a BIM execution plan, which tells the employer that you understand their requirements and here is your proposal and plan for addressing those requirements. So the EIR will tell you what information, I want some documentation, when do I want that documentation, I want graphical models, I want 2D drawings, I want non-graphical data, and I want to tell you exactly what format I want it and when I want it during the course of that construction period or design period. And the sort of grayed out diagram at the bottom is just taken out of one of the standards. That shows, you can't really see, it just shows a cycle of information, and then it's sort of broken down into the various standards, and it sort of helps you identify or go through that process of identifying those requirements and prescribing them. So the PAS 1192 series of standards is well worth a read if you're interested in that kind of thing. I'd say it's a very exciting read, but it's something you should really bring yourself up to speed with if you want to know anything about BIM. So the PAS 1192 series was a British standard. It's now become an international standard, and you now see it being used in Dubai, in United Arab Emirates, in Singapore, in Australia, in New Zealand, and all over the world. So it's been quite a success story for the UK. Also, you need to be thinking about not only the information, but again, I talked about it before, about the systems that you're going to use. Do you need to prescribe any standards? Before, I talked about open data standards, so you'll hear about things like COBie. So COBie is a standard that describes the structure of data as it is passed from system to system. And IFC is a standard that's used to describe how information is passed between 3D modeling systems. So lots of software providers will now incorporate the import of an IFC model into their own software. It's not perfect. You do lose a certain amount of fidelity and information as you import it. But also, as an employer, if you're starting to specify these things in your EIR, you need to be thinking about, maybe I should specify some standards. Maybe that's something I want to tell my supply chain to use. And also, another important thing is something there called master data management. That's probably a lecture in itself. But that's, as an organisation, particularly a lot of clients, there's a lot of work I do is going into clients and help them understand what information they manage already. Who manages that information? How do they make it available? Who wants that information? Because many organisations actually don't know that. You know, they carry on in their own business and they manage information in their own way, but they probably don't realise the level of inefficiency that they currently have in their business. So just by asking a few simple questions about, does Joe over there have a spreadsheet with, I don't know, all the HR information on it, and that's how he manages it, how does he make that available? Because actually knowing who's working where and what they're trained in would be really useful to know out on site. But actually it's sat on a spreadsheet that's not connected to anything else. So actually doing a job of work and identifying how that all fits together is all part of the journey that you need to go on. Again, there are lots of standards, so I just pick out a couple from here. So there's a standard called Uniclass. It's a standard way of classifying things. So assets, be they groundworks, be they concrete structures, be they steelwork. It's just a standard that says you will describe it in a certain way, you will classify it in a certain way. So every single component is broken down into a hierarchy and given a common code. And it's a neutral standard. And many organisations now in the UK are starting to adopt Uniclass as a standard way of describing things. Now, just to give you an example of why that's good, if you're a contractor and you're bidding, so say I'm bidding for work in Environment Agency and I'm bidding for it in Highways England, and they have two different ways of classifying things, then I've got to come up with two approaches to price it. If they're doing it the same way across multiple clients, I'm saving an awful lot of money in procurement cost across multiple clients. So immediately there's a saving there, as an example, to the whole industry actually in procurement. So I'm going to give you a few just specific examples now of how BIM is used, and forgive me, some of these may be quite familiar. BIM actually started in design. That's really where the whole concept of information management and why 3D models are often associated very closely with design. No coincidence, because it sort of was spun out of the engineering industry from 2D CAD into 3D models, and then those models could actually have described objects in them. So the example I've got here is actually a Crossrail station. So if you look at one of the main running tunnels there, is a solid cylinder. Well, in that model, that's all it is. But you could, if you clicked on that, get to a whole load of more information about that particular running tunnel if you wanted, and cross passage, etc. So enriching the information in models is kind of where BIM started. So BIM has been used in design probably longer than anything else, really, and that is to model things in 3 dimensions. It allows humans to interact with the information in a more meaningful way. We interact with 3-dimensional things better than we do 2D. I noticed that a lot in Crossrail when we started to show 3D models out on site to people who perhaps weren't engineers. So when you're engaging with the client and getting them to understand what things will look like when they're built, people really understand 3D. They can really begin to see what things are like rather than putting a load of 2D drawings on a desk, which requires a trained engineer to try and infer and explain what that's like. So BIM has been used in design and actually construction quite a lot. In construction, here's another example, and shamelessly, I've used a lot of examples from Crossrail here. Forgive me, it's just because it's probably the best source that I've got close to mind. So if you're taking information into construction, so on the left-hand side, installation progress reporting. So it's exposing information to those in the field as to what is the cost of the sequence of construction, and exposing that information to the people who are doing it so that they can analyze and model that data and do things better. So it's exposing information to people so that they can see where the inefficiencies lie. And we know that this led to some efficiencies in time savings, process improvement, we got better quality records, good assurance data, better maintenance benefits at the end as well. One interesting thing I will mention is, however, that when you have better data and you start exposing that to people, it has a kind of counterintuitive effect. On the right is 4D. So 4D is taking 3D models and adding time, the fourth dimension, to it. So you can run things through in time and see what construction and sequencing look like. But it does require good input data. So good plans, good programs, good Primavera plans, good Microsoft project plans, whatever it is you happen to use, or Astor Power Project Team Plan. Others are available. And once you couple the program to the elements of construction, because that's how you assemble a 4D model, you get quite a lot of power out of it. One thing we noticed out on site was that we realized by using that data more how poor actually that data was. And people, particularly planners, started to see that as a threat, because we were starting to ask questions of them, saying, actually, what you're giving us isn't very good. And so, what do you mean it's not very good? This is what I've done for 20 years and nobody's ever asked me before and said that it's not very good. It's just that, and we have to sort of be non-threatening and say, look, okay, you know, let's have a bit of an amnesty about this. Okay, your job's not under threat. We just, you know, we want to get to a good end result here. So we need you to be providing better on-point programs that we can use. And this is just another example of kind of the cultural barriers that you can have sometimes. On the face of it, what I'm describing, if you believe me, seems quite good. But actually the process of getting people to do it is actually very hard. And that example I've given you about, you know, not upsetting people, because suddenly you might be threatening the job that they've done for the last 25 years, you're going to get a whole lot of defences thrown up in front of you. So having a good people skills, as I'll come back to later, is absolutely essential, and when you're going through a sort of a change program. Many of you in this room might be, I know I was sort of a past site worker. I always think with BIM you have to answer the so what questions. You know, I could ramble on for years and years about you know, technology and the opportunities, but ultimately if it's not something that makes your job easier, then you're not going to want it. And at Crossrail I was responsible in rolling out some mobile applications to the mining engineers out in the field and telling them, and rebar engineers telling them they didn't need to use paper anymore and didn't use clipboards anymore. We was going to give them an iPad and that was going to make their job easier. But when I sold it in terms of technology, they just weren't interested. What they really needed to know that it was a tool that they could pull out their bag and it was going to make their job easier. So a slide like this is really helpful because it actually sort of speaks to the guy in the field. Is that if I can give that guy better information, wouldn't it be good if, for example, when I'm looking at an asset or something in the field, I can see the current status on it. I'm visualizing it. I know when it was installed. I know who installed it. If I can combine information from multiple sources, perhaps when I'm on site, that might help me in the field as well. Can I access that information easily? One of the problems we had at Crossrail was that many of the site offices were at least 20 minutes from the workplace. So guys who were going out and doing inspection and testing, especially the field engineers, were going out from their offices with bits of paper and cameras and all sorts of things, walking 20 minutes out to the site, recording lots and lots of information, walking 20 minutes back because they'd forgotten something, then going 20 minutes back, then 20 minutes back again to sit at their desk and double enter that information into a system. It was clearly ludicrous. But if we could give them that information offline in the field at the point of activity, so their method statement, their inspection and test plan, all in hand, maybe they're doing a concrete cube test or something like that, they can have all the information there when they need it, record the results on the device, offline. They don't have to keep walking backwards and forwards. You don't have to explain to me that that's going to make their job a lot easier. So once we'd sold it to people like that, and that did require us to spend a lot of time understanding health and safety challenges and how their jobs worked, etc., and got them on side, it became a whole lot easier to sell the new technology. Lots and lots of technological solutions go wrong because arrogantly we walk out there and we just think this is going to be the right thing to do, and we impose it upon people. We don't actually talk to the people who are doing the job. And if you involve them, more likely you end up in success. So creating a dialogue like this slide often speaks in common sense terms to people and gets their buy-in. Another example, this is a Crossrail example, it's Tottenham Court Road and Liverpool Street. It was also done at Custom House. It's what's called offsite production, DFMA. Again, not a new idea. We did it in the 1960s in this country. We didn't do it particularly well because the quality was poor. We know that because buildings only lasted about 20 years and we started tearing them down. So offsite factory production is being revisited now, and Lang O'Rourke, actually, that's why I've included their logo here, are right at the forefront of that for what they call their Explore Park facility. So Ray O'Rourke is a great passionate advocate that construction should work in the same way as building aircraft, as building boats, as building ships. Those industries have been through huge transformations in the last 34 years and are driving productivity levels that we could only be deeply envious of. And we've always arrogantly sat back in construction and said, but we're different. You know, we work outside in all weathers. You can't have off-site production working in our industry. It just doesn't work. Well, companies like Lang O'Rourke are completely challenging that notion. So traditionally, on the Crossrail sites, it was cast in situ construction, pumping concrete 30 metres underground, and that's how the design was done. Lang O'Rourke was saying, no, we'll assemble all the platform copers, we'll assemble the whole stuff on a factory production line, and then we'll drop it down into the station and we'll assemble it in situ. And I won't read after the productivity figures there, but the analysis proved that there was a huge 150% increase in productivity by doing that way. And in fact, on Crossrail 2, if it actually comes to fruition, I would imagine that most of the stations on that programme will be done in what's called a DFMA, Design for Manufacture and Assembly methodology. That's using the design model as a manufacturing model at the production site to drive production at component level and then control the whole shipping of that component from the manufacturing site, from design through manufacture to the site, so it's dropped in place and fits perfectly. Now, I know I said we didn't do that very well in the 1960s, but the evidence would suggest that now we're doing it a whole lot better. Higher quality standards, etc. Look at China, where they're now throwing up homes now that you can sort of buy off plan, they'll turn up and they'll assemble the entire house in a day. So it is possible, it is being done. Laser scanning, so another technology, it's all about, this is information capture. So capturing your as-built condition. So this is the concrete lining of Connaught Tunnel. So in there was a particularly, I don't know if anybody was involved in Connaught Tunnel, but you've got an old Brunel Victorian tunnel that had to be refitted and adapted to take the new running trains. So it's an interface between new and old. So knowing the existing infrastructure condition, couple that with the new, so what you're seeing here is a laser scan of the sprayed concrete lining that was put in, just to test the integrity of it, the tolerances of it, and then seeing how that would then augment the design further down the track on the right hand side. So laser scan information, data and point clouds, and merging that with a three-dimensional model. We did it also on a number of sites where we had station boxes. So we had one contractor moving in after the other, so we'd scan the box just to make sure that the tolerances were right, things were upright, they were all in the right place, and providing a more accurate as-built reflection of that box to the follow-on contractor, rather than the pour-on contractor having to rely on the condition of the old as-built drawings, which more often than not, when they were handed over in that transition, proved to be an inaccurate reflection of what actually they had there, and there was lots of remedial work to put it right. So I've taken you on a bit of a journey, hopefully. I've tried to share with you the essentials. I hopefully tried to demystify things. It is quite a complicated subject, I won't deny it. But one thing I just wanted to kind of finish off on really is that we are crying out for people who are proficient in this area. People have sort of turned their noses up a little bit and said, you know, BIM will never happen, digital will never happen. I can tell you it is. It's happening in a big way. The UK government is driving it. It's happening all over the world. I don't have enough people in my team who are not only engineers, not only have a technical appreciation of some of the things that I've described, but more importantly, that they have the ability to communicate and demystify. So one of the things I've tried to do today is to do a translation exercise between a technically difficult subject and answer some of those so what questions. We just need more people. We've got plenty of people who are perhaps CAD technicians or 3D modelers or who understand the technology, who are pure civil engineers. But the type of roles we need now, and whether you want to call them a digital enabled engineer or whether you want to call them a BIM technician or a digital technician, a digital consultant, we need more of them. We are at the vanguard of it now, and the reason why I'm so busy is that I'm one of the few people who've become one of these hybrid beings that are doing this. There's lots of work. We've been very busy since Christmas, doing lots of work with lots of clients, trying to do these things. They're being driven, and we are struggling to satisfy that demand. So when I was last here listening to the industry talk, there was a really interesting discussion about Brexit, actually, funny enough. But don't get me started on that. But it was more about the amount of construction going on in this country irrespective of Brexit. So if you've got High Speed 2, you've got Crossrail 1, you've got Crossrail 2, you've got Heathrow expansion, you've got Hinkley Point, you've got hundreds of billions of pounds being spent in this country building roads, building bridges, building plants, and we don't have enough engineers to build them. So really the whole Brexit argument is irrelevant. There's huge opportunity in this country for construction, so don't be worried about that. But for me, in digital, that's a new frontier, and I need new people to come into that industry and help me deliver it. So, not sure whether I'm on time, Hugh, but I'm very happy to take any questions that anybody has.
Has BIM taken into consideration in the modelling of, so you're referring to like Lang O'Rourke saying they're trying to implement things into the aviation and the shipping industry, which is all upgrade stuff. How do they take into consideration ground conditions, specifically things like water that can potentially vary?
Well, I think, again, to my other principle, it's knowing more about the conditions that you, rather than digging a few trial pits, it's mining into information that might come from others. So it might be geological information that now is increasingly held within databases. And there's technology now like ground penetrating radar that will tell you a lot more about that condition. So we can't ignore it. It's never going to be the same as a nice dry prefabrication facility as you would get in Airbus. But I don't think we should use that as an excuse, because we now know more about the environments we're working in. So if we took the time to gather the data that we know, give an example at Hinkley Point. So Hinkley Point A, when it was built in the 1950s, was decommissioned, dismantled, and they buried a load of asbestos in the ground. Okay, so when we started digging into the ground, we found the asbestos. We then spent 3 years remediating the ground to get rid of the asbestos. If those records had been kept somewhere and we knew what the ground conditions were, we could have foreseen that very, very early on. So I take your point. I don't think we'll ever be the same, but the point is I think we now have the technology and the information being stored by people like Ordnance Survey, local councils, that's digital. So if we leverage that data more, then I think we can do better planning.
How do you ensure you're not being driven by technology providers?
Yeah, it's a really good point. Unfortunately, I think we are, to a greater extent, being driven by technology providers. Another example I'd give you without naming anybody is that you think about the iPhone or the iPad. Again, other mobile devices are available. But the iPhone and the iPad were sort of a hugely disruptive innovation. They just suddenly arrived, and you found loads of companies just buying them. Who knows why? I mean, they just, because out of vanity, I don't know. And then they were allowing what they were doing to be adapted by the technology, rather than thinking fundamentally about the information itself. So I think the only way you counter it is that you've got to be agnostic to technology when you're thinking about information. Don't think of it in terms of software manufacturer A or technology B. Think about the actual information you need, because if you do that, then you're going to come up with a really good set of requirements that translate into system requirements that then allow you to turn the tide on the software vendor or the hardware vendor, because you're going very firmly to them and saying our industry needs technology that will do A, B, C, D, and E. And if you're going to change technology vendors, you have to incentivize them through their commercial imperatives. So if they're going to earn money out of that, you're their client, and you're not going to buy their systems if it doesn't do what you want, then they will change. Unfortunately, because I don't think we've been so wise to information, we have allowed ourselves to be led by technology vendors. Again, I'm not being unduly critical of the technology vendors, because we need that innovation. And if I was working for a technology vendor, I would pretty much do the same thing. But there needs to be a slight change. There's an imbalance, and always has been. So you raise a very valid point. I can't tell you that that's not still happening. It probably still is. But there are more and more companies now thinking in that system agnostic way to try and get the right solutions that you really need. That makes sense. Anybody else?
I have a couple of questions.
Yes, sorry, I'll come back. Yep.
So first of all, you're saying is the government going to drive this and get behind this properly? First of all, how much is that going to add on to the front end, especially like when I said design development? Because there really is no limit to how much you put into this and how well you can develop it.
It's kind of to answer that question. So we've been lucky in this country to have, and I often say this about government, so that they have been visionary. They were back in the financial crisis of 2011, for whatever reason, and probably because they were driven to it, like crisis innovation, that they suddenly saw, BIM had been around for years, that suddenly this thing was going to save them 20% in capital infrastructure delivery. So having them advocating that, having them being cheerleaders for that has been fantastic. And in fact, they continue to talk about construction 2025 and digital built Britain. My slight criticism is that they haven't tangibly turned that leadership into tangible guidance for companies, kind of left industry to try and work out how to do that themselves. And I think that could have been done better, but that may be being harsh, I don't know, because many countries just don't have that leadership. You are quite right that you're going to have to start thinking with BIM in terms of longer periods of time and longer payback periods. You know, we're kind of obsessed in Anglo-Saxon countries particularly about a return on investment within months and years, you know, a month and a year, rather than perhaps in Scandinavian countries where they were very early adopters of BIM because they looked at it from a 5-year, 10-year life cycle. I was certainly challenged at EDF to demonstrate that a digital strategy, for every pound that we spent, we would get a pound back. That's kind of not how it works. There's an area under the curve, which is your investment up front. Okay, it'll certainly cross the curve, so the area under the curve is certainly smaller than the area above the curve. But the real payback for BIM certainly comes in construction. I don't know what the magnitudes will be. Maybe it gives you a twofold payback. Yeah, but in operations, so if we think about Crossrail, 150 years that's going to last for. So 150 years of improved operation is probably a 100 times payback. But that's not going to come for 10, 15, 20 years. So you're quite right. There needs to be an understanding of what the return on that investment is, but it's going to come later. And I think we're kind of sort of a little bit flawed in this country because, you know, we tend to work on very short timescales, very impatient about getting that money back. So I don't have an answer for you, but government does have to have a role in trying to de-risk that and explain to clients in particular that it is a worthwhile investment.
How long then do you think would be before that trickles down to the likes of the supplier? Because obviously, you know, you've got the likes of your approved register, which companies pay to get on.
Yeah.
Yeah. Choice.
Yeah.
So presumably then this can only lead into an area where suppliers will have to provide or able to provide this information digitally, so the likes of your AIM and asset model.
I think it's an aspiration that will trickle down, and there are certain techniques that are being done. So High Speed 2 has a compliance regime around procurement, so they're beginning to look at capability assessments of their supply chain. So they're beginning to get them to rate themselves, and then they rate them and they'll say, you know, are you BIM level 2 compliant, for example? And if you are, then great, and you can demonstrate and you can prove it, and that by implication means their supply chain, right? So the hope is that by doing compliance and capability testing upon the tier 1 type contractors, they in turn, and it is just a hope, are then going to impose that kind of capability assessment down to tier 2, tier 3, tier 4 and manufacturers. Yeah, I think there's evidence that it is happening. Is it happening fast enough? Probably not, but it's a bit of a revolution. You know, a lot of these manufacturers are going to have to retool. They're going to have to retool in terms of the way they manufacture things, but also the way they work and understand the implications of that. So that education top down, I think, is being left as a trickle down kind of effect, so it's sort of diluting as it goes. That's my perception anyway.
The last one, so were you involved in the asset tagging and asset attribution?
Yeah, that was Ross Denton, who I was the interface between the technical information team and I was more delivery focused. So my job was to understand what those requirements were and try and get it to work in reality. So, you know, there are a lot of myths around Crossrail. So there were things, I think a lot of what Crossrail did was, it was the pioneer, and that implies that it did some things good and some things it learned. Yeah. So I think on the asset tagging, I think and there were two aspects to that. It was physical labeling, because they wanted to reduce the amount of physical labeling, and then there was digital tagging, and then was how they would then tag that electronically to other records. And I know, because I was out in the field, how difficult that was proving, even from simple labelling light coffers in Paddington to trying to think of other examples, but it proved to be impractical, so we couldn't do it. So we had to work very closely with the contractors and listen to the contractors and say, actually, you shouldn't be doing it that way. So
we're going through the process of custom house now. It does seem to be that disconnect between what we're asked to provide to get us over the finish line. What should be, what feels like it should just be a kind of click where you should be able to just digitally just upload it straight away rather than having to go through the set of drawings and run through that process.
Yeah.
I think it's a good system for us to have like that kind of level of kind of rationalizing as we totally.
But I think they were only ever going to learn by doing, weren't they? I mean, a lot of it was aspirational, never been done before. We had a lot of battles with London Underground about the granularity and the attribute level of description we had within cross passages and tunnels, where they were saying, well, we just don't tag those things. We never have, we don't need to. And we were saying, oh, no, we're going to tag cross passages. We're going to tag every fourth chamber ring, tunnel ring. So that's lunacy, why are you going to do that? And we had to create this argument to London Underground that maybe they didn't have the capacity to use that information now, but 5 years in the future, when the systems are upgraded and the cost of looking after data is relatively small, then we're going to go and see, this is my payback analogy again, but I think there was an attempt to try and work with the contractors to adapt some of that. I don't know how successful that has been. I've heard varying stories, but I think what you can't criticise Crossrail for is they tried to do it. So I think it was a good idea, and maybe it'll be the legacy, it'll be the learning that comes out of what was done on Crossrail, how that translates to Tideway, or which seems to be where a lot of the learning is going now, or High Speed 2, where not much of the learning is going, or to Crossrail 2. So, and that'll be the trick. It's these big projects over long periods of time are more likely to learn the lessons and then pass them on to other projects, but that'll take a long time, and it won't necessarily be done in the most effective way, I would guess. There's a question here.
I'm assuming the success of BIM on a project depends greatly on the quality of the EIR at the offset of the project. And you mentioned the confusion regarding BIM, and so my question is, do you see kind of much improvement in translating the client's initial thoughts on BIM into the actual EIRs, kind of save compensation events and everything else going forward?
It's been quite tricky, I think, partly because I think in some cases the supply chain, the tier 1 contractors, are often smarter than the client. I mention no names, but we're involved with some large government departments now, and either they haven't got a clue, or if they have got a clue, they're not asking the right questions, which leads to very poor requirements being put forward, and then you end up getting information that they either don't need or they can't use. So it's difficult. You need to have there's an education to be done on the client side. There's still a lot more work to be done there, I think, and it will only, I think, really be a success when the clients begin to understand the value of information.
And can you see any lessons learned from the cross-revenue rights that you need to go back to the client side and kind of improve the EIRs that you're looking at?
Some, but that was a difficult journey because you had multiple